Hello there. I'm Linwood Fields, your green instructor. This is lecture 3 in dimensional analysis. This lecture is about dimensional analysis in action. The objectives: we want to know what a unit is and understand how to use dimensional analysis to solve a problem. Finally, dimensional analysis. The big moment is here. The following problem will teach us everything we need to know about dimensional analysis. Here's the problem statement. We have a big bag of juicy, delicious apples. There are 10 green apples in the bag for every 5 red apples. If there are 20 green apples in the bag, how many red apples are in the bag? So using dimensional analysis, we don't have to guess. This technique is proven to give you the correct answer every time. The fact that there are 10 green apples in the bag for every 5 red apples is the key. Our answer will have 2 parts. Yes, 2 parts. It will consist of unit and a number. The unit is the object of concern here. In this example, red apples, because we are trying to find the number of red apples. The number is the amount, or how many red apples. A unit is a precisely specified and agreed upon amount or extent. For example, a meter is a unit of length. In other words, a meter is a precise distance that the scientific world has agreed to use. When we say our units are red apples, we are using the concept of unit rather loosely because there is no precisely defined and agreed on apple amount. Here's the dimensional analysis recipe that you need to master, because you'll be using this for the rest of your life. It's a 2-step process involving multiplication, division, conversion factors, and units. Step 1. If a conversion factor is not given, then you have to make one. Then take care of the units part of the problem. Step 2. Take care of the number part of the problem. As far as the mechanics are concerned, we just multiply what we are given from the problem statement by our conversion factor. So this will become clear shortly. We write our conversion factor so that the units in our answer are correct. Again, we write our conversion factor so that the units in our answer are correct. That is the key. If you end up with the correct units in your answer, then the number part is going to take care of itself, as we shall see. Okay, I put the bag of juicy, delicious apples in the upper right hand corner here so that you remember that this is the problem that we're solving. Step 1. In our problem, we know that the units in the answer have to be red apples because that's what we're trying to find. Let us go ahead and make ratios. There are 10 green apples for every 5 red apples. Or I can say that there are 10 green apples per 5 red apples. Remember, per means to divide. So here are our two ratios, or here are our two ratio or conversion factor choices. 10 green apples per 5 red apples, and equivalently 5 red apples per 10 green apples. So in step one, we were not given ratios, but we had to take the problem statement and form our own ratios. We're still in step one because we are still taking care of units. We know that the answer has to be red apples, and we are given 20 green apples. So we have to choose our ratio so that green apples cancel when we multiply. So this is a very crucial step right here. Choosing the correct ratio of the two choices so that we have something to cancel. Very important step right here. So again, here are our two ratios. So let us choose the ratio on the right, this one here. Then we write that ratio down and multiply by what we are given. We are given 20 green apples. So we can already see that we might have something that will divide out. But I need to show you one more little simple step before it becomes clear that you will have something that will divide out. Okay, this next step is we're going to write 20 green apples as a fraction with a denominator of 1. And that's what we've done right here. 20 green apples divided by 1 is the same thing as 20 green apples. So we wrote this as a fraction so that it becomes clearer to the fifth grader that we have something that will divide out. And we can use the same object division rule. Here, it will allow us to cancel green apples because notice we have green apples in the numerator and we have green apples in this denominator. It does not matter if green apples is in one numerator and then it's in the denominator of the other fraction, because we could rewrite these fractions. We could put the 1 over here and we could put the 10 green apples over here. Okay, so the important thing is we rewrite the 20 green apples as a fraction with a denominator of 1 so that we can more clearly see that we have green apples that will cancel each other out because we got green apples in the numerator and green apples in the denominator. Now we are left with only red apples as units, which is what we want for the units because we're trying to find the number of red apples. At this point, our solution looks like the following. So we went ahead and wrote down what we had left for units. We had red apples left over because they did not cancel. Green apples canceled, so they went away. This question mark right here reflects the fact that we have not completed the number part of the two-step dimensional analysis process, which we will now do. So we have finished step one. We have taken care of the units. And again, in step one, we don't worry about the number part. We don't worry about this 5, this 10, and this 20, and this 1. We don't worry about that because we are trying to take care of the units part. Okay, step two, let's go ahead and take care of the number part. We can now forget about the units and just write the fractions with the numbers only because we've already taken care of the units. So we're going to write 5 divided by 10 from this fraction here, and we're going to multiply that by 20 divided by 1, 20 and 1 from this fraction. So notice here, down here, we have left off the units. You don't see apples written down anywhere because we've already taken care of the units in step one. So to multiply fractions, we multiply the numerators. 5 times 20, and then we multiply the denominators, 10 and 1, 10 times 1. So we multiply the numerators, 5 times 20, and we multiply the denominators, 10 times 1. 5 times 20 is 100. 10 times 1 is 10. 100 divided by 10 is equal to 10. Our complete solution looks like the following. We have our units in red apples. Remember, that's what we're trying to find. And we have the number part, 10. 10 red apples. So this is our complete one-line solution. So this is the beauty of dimensional analysis. You have a one-line solution. Does our answer make sense? Yes, because our ratios tell us that there are half as many red apples as there are green apples. So if we know that there are 20 green apples, then there must be 10 red apples. Why? Because 10 is 1/2 of 20. To convince yourself, go back and count the number of red apples in the bag. So for students and anybody solving problems, it's always a good thing to go back and ask yourself, does my answer make sense? Does my answer make sense? You should get in the habit of doing that. It will help you to get more points on your test, and when you start working, it'll help you to solve problems faster because you will detect problems before they get out into the field. This may seem like a lot of work, but we have only performed 2 simple steps. First, we formed conversion factors and used same object division to cancel the green apples. Then we performed fraction multiplication. The beauty of dimensional analysis is that we do not waste time deciding if we should multiply or divide. Also, we do not waste time trying to decide which unit is larger. Current 5th grade books do just that. The student has to decide which unit is the largest and if they should multiply or divide. In the real world, problems are solved using the mechanics of dimensional analysis. They are not solved trying to decide which units are larger and when to multiply or divide. You could do it that way, but you're wasting time. Time is money. With dimensional analysis, use the correct ratio, and the units part of the answer takes care of itself. After the fifth grader masters dimensional analysis, they will be set for life when it comes to performing units conversion problems. Wow, this is an important skill to have in one's toolbox. Now, what if we choose the wrong conversion factor? What if we had started with the other conversion factor? In step one, we would have the following. We would have 10 green apples divided by 5 red apples, as opposed to 5 red apples in the numerator and 10 green apples in the denominator. And then after we rewrite the 20 green apples as a fraction with a denominator of 1, as we have done over here, we immediately see that we have a problem. There's a major problem because we cannot use the same object division rule because there is nothing we can divide out. Neither green apples nor red apples appears in both a numerator and a denominator. Green apples appears in 2 numerators. Red apples only appears in the denominator of this first fraction. In order to have something to divide out, we need for the unit to be both in the numerator and the denominator. Here, green apples appears twice as a numerator. Never does it appear as a denominator. Red apples appears only once. So because it only appears once, it cannot cancel out with anything. So we recognize we have made a boo-boo and must use the other conversion factor. 5 red apples in the numerator and 10 green apples in the denominator. This will not work. That's a boo-boo. This is why this problem-solving technique is called dimensional analysis, because we choose the conversion ratio and then analyze the units to make sure our answer has the correct units. And then the number part will take care of itself. Now, we probably could have called this unit analysis because we are analyzing units, but it is known as dimensional analysis. Summary. A unit is a precisely specified and agreed upon amount or extent. Dimensional analysis is a two-step process. Step 1, take care of units. Step 2, take care of the number part. Here are some questions and practice problems, but these are questions and practice problems from our last lecture. I forgot to put these at the end of the last lecture. So these have to do with same object. These have to do with vertical reduction. I put the dimensional analysis problems at the end of the next lecture because we are going to solve more problems in the next lecture using dimensional analysis. You are not expected to have mastered dimensional analysis from this one example. This is the end of lecture 3. Thanks for your attention. Join me the next time in lecture 4. Goodbye.